Hello everyone. In this video we are going to see our wireless sensor network protocols. So basically there are different types of protocols. First one is sensor management protocol. So whenever we talk about sensor management protocol, as the name suggests, management, its work is to administrative task like moving the sensor node, turning it on and off. Then comes our sensor query and data decimation protocol. Basically this protocol is very important for data communication. It provides users application with the interfaces to issue and respond to the queries. And sensor query and tasking language SQTL comes under this. Then comes our direct diffusion. So what it tells is what actually it is a method of data decimation in distributed sensing scenarios. Basically data generated by the sensor nodes are identified by the attribute value pairs, and the sync node that requires the data send out interest that they want to receive the data into the network, or they want to send the data to the network. The data generated by the source node that matches these interests flow towards the sink, and intermediate nodes are capable of catching and transforming the data. That is a directed diffusion. Then comes our sensor MAC. Basically sensor MAC, a MAC protocol designed for wireless sensor network. When we talk about the characteristics for that, its energy consumption and self-configurable is our characteristic of the sensor MAC. Then comes IEEE 802.15.4. It's a most important protocol which we will going to see in the upcoming videos. Then there comes IEEE 802.15.4. When I talk about IEEE 802.15.4, this standard offers a physical and the MAC control layers for low cost, low speed, low power, wireless personal area network. When we talk about the history of this, so it was formed by the combination of two standard groups. Number one is our ZigBee Alliance, and second is ZigBee Alliance, and second is IEEE 802 Working Group 15. 802 Working Group 15. So Working Group 15 given the task to Task Group 4 to develop the low rate wireless personal area network. The Task Group 4 formed in December 2000, right? And then there comes IEEE 802.15.4 approaches for the low power. In order to achieve the low power and the low cost goals established by IEEE 802.15.4, there are some approaches that was followed. First was to reduce the data transmitted. So basically when we want to consume our less power in data transmission, what we have to do? First process is to reduce the data. See, if we reduce the data which we want to transmit, what will happen here is we can reduce the power consumption. Second is reduce the duty cycle. So duty cycle means if we transmit our data in very slow pace, so then and frequency, then what we can do is we can use less power. Decrease the overhead. That is one also point. Decrease the complexity and the range. If we reduce the range, then also we can use the low power. And send data and sleep. This is one of the most important. Like this is our sensor, it sends the data and just switch off, sleep. That is our saving our power because it's not getting switched on. So this is the mode of IEEE 802.15.4. So when I talk about IEEE 802.15.4, there are actually the two classes in that. Okay, one is full function device, other is reduced function device. When I talk about full function device, it's mostly power device, and reduced function device get power for very less time. Basically it sends data in the sleep. It acts the PAN coordinator, right? So because it is every time it is switched on, so it will act as a PAN coordinator and it will be connected with the leaves of the network. If I talk about the star connection, and if I talk about the reduced function device, it gets power for very less time and sends data in the sleep. Basically leaf node, what happen here is our main node is there, it sends data, right? PAN coordinator is there, it sends data to the leaf node. Leaf further send data and it will turn off because there is no need for the leaf to turn on. So next thing is our topologies. Topologies in 802.15.4. So when we talk about topologies, there are actually different topologies, right? First topology is our star topology. So as you see in this figure, this is our star topology, in which the center one, the red one, no sorry, the center one, this is red one, is our PAN coordinator, and the blue one, this and this are the leaf nodes. Sensor node communicate with the base station PAN coordinator directly. So sensor node is there, okay, it will directly coordinate with the PAN coordinator, and it is energy consuming. Leaf may be any combination. It can be a FFD like full function device or reduced function device. So here what happened here is, if we see the example here is PC peripherals which may require low latency connection of the star topology, right? Then comes multi-hop scheme. In multi-hop scheme, what happened here is there is one PAN coordinator and there is blue one is our leaf nodes. So PAN coordinator will send data to the leaf node, and with the help of hopping, that's why it's known as multi-hop scheme, like peer-to-peer network. This will hop here, then again it will hop here, wait, it will hop here, again it will hop here, here. In this fashion it will move the data. So transmit through some intermediate nodes. So these are my intermediate nodes, these are intermediate nodes, all are intermediate nodes. Fine. It's energy consuming because it sends data and leaf node will see and it will sleep. It's energy consuming. Parameter security which needs larger coverage area may require peer-to-peer networking. So what happened here is, if the distance is large, we use FFT, and if energy constant we use RFT. Then comes our cluster. Now we have already seen cluster. If we go to some restaurant or we can call it as some staying at some place, hotel. So what we see here is there is one HVAC system, that is heating, ventilation and air conditioning system, which is connected to our base station, right? And there are different rooms that are connected. So what we can do here is, so that are leaves that connect to a network of coordinators, FFD. Here one coordinator act as a PAN coordinator, and the cluster star topology are important case. See here different types of star connections are there. What we studied here, star topology, every star topology will be here in this circle. So this is kind of heating, ventilation and air conditioning system also. Now there comes leech. Leech is what? It's not some animal. It's low energy adaptive clustering hierarchy. Low energy adaptive clustering hierarchy. So clustering is dynamic. Basically any node can work as a cluster head in leech, right? So what happened here is, it is designed for sensor network where an end user want to remotely monitor the environment. See, we are having some system where we would have an end customer or end individual who basically want to monitor the environment. For that purpose we use leech, and data from the individual nodes must be sent to the central base station, basically that is often far from the sensor network. Desirable properties for this protocol on the networks are, it uses 100 to 1000 of nodes, which maximizes the system lifetime, maximize the network coverage, use uniform battery operated nodes. So here what happen is, it's a distributed clustering and the local processing it provide. Random rotation of the cluster head makes it energy efficient because it will try to change its cluster head. So if some node is damaged, so that must be shifted to another node, and there is no lag in our system because our node will be changed after some point. Then comes our network layer guidelines. So whenever we talk about IEEE 802.15.4, it does not address our network layer. First of all, why it does not address? Because the network and the higher level are basically left to the industry, right? Network and higher level are left to industry. And the service which network layer provides are more challenging to implement because low power consumption requirement. Why? Because why we are working with 802.15.4 is because of its low power requirement. And when we are not able to get the low power requirement, what is use of using this standard? That's why we are leaving that network that to the network layer, right? We are giving that network layer to the industry so that they can handle on their own. Expected to be self-organizing and self-maintaining to minimize the cost to user. There are different network topologies that are supported, like which you already seen, that is star topology, peer-to-peer topology, and the cluster topology. Now we will see the IEEE 802.15.4 system layering. When we see that, I already told it does not see the network layer. Basically what it sees is a data link layer. Here we are having a data link layer. This is, and this thing is left to the industry. So data link layer is divided into two parts. First part is our logical link layer and second is a sub MAC address. Whenever we talk about logical link layer, that is LLC, logical link layer, it's standard of 802.x standard N. It communicates with a MAC, and where is our MAC? This is our MAC. This thing communicates with our MAC through SSSC, that is Service Specific Convergence Sublayer. Proprietary LLC can communicate directly, right? MAC sublayer is a data service, a common part of the sublayer. This is a common part of data sublayer, and management service to handle the management entity. That's why we use MAC layer here. Next things comes under this is below data link layer we are having our physical layer. So we will see the physical layer. So basically in physical layer what we are having here is we are having the two frequencies, that is 868 to the 915 megahertz we can take, and another one is our 2.4 gigahertz. So whenever we talk about this frequency 868, it provides 20 kbps per second, 915 40 kbps per second, and 2.4 gigahertz provides 250 kbps per second. And then if you see our MAC layer, this one MAC, so it provides a data and management service to the upper layer, as I already told, and 802.15.4 is very complex, making it very suitable for intended low-end applications. Smaller feature it provides that does not support synchronized voice links. If you see the MAC frame here, it has 64-bit physical address and 16-bit short. Address field 0 to 20 bytes. So this is my physical layers which I have already written. Now comes our frame formats. There are different types of frame formats which are beacon frame, command frame, data frame, and acknowledgement frame. Beacon frame is broadcasted to organize a network. Command frame for association and disassociation of the beacon request. Data frame for carrying the data of the user. Acknowledgement frame for acknowledgement successful data transmission. These are the 4 frame formats. Then comes our interface. Common in 2.4 GHz band, other service operating in that band, right? Now we will see this in the next video.